All right. So yesterday we were learning about how to find x and y intercepts either from a graph or algebraically. So today we'll be actually graphing using the x and y intercepts. So to find the x-intercepts, we put that, well, first we have to find the x-intercept, and how do we do that?
Substitute zero in for y.
Yep, if we're given an equation, you plug 0 in for y. So when we find that, we put that point on the, having the pen would certainly help, wouldn't it? Put that point on the x-axis. And then how do we find the y-intercept?
Put 0 in for the x.
Right, put 0 in for x if we're given an equation, and we solve for y. And then we put that point on the y-axis. So we are given 2 points. I'm just gonna do something for example. So if we have 1 point there and 1 point there, we then draw the line that would be connected by those two. So this is just an example. It will look something like that. All right. So if you would be so kind as to turn to page 239 in your book. We'll be doing the, check it out, 3A. And we're asked to graph that equation by finding the x and y intercepts. So to find the x-intercepts, we,
Mr. Conlon,
yes, Cody?
that's actually not 3A.
It isn't?
No.
239.
Yeah,
3A?
It is. You're looking at the wrong one.
You're looking at the capital A.
There we go.
Oh,
Sorry. All right, so we're trying to find the x-intercept, right? Or finding both of them. But first we're gonna do the x-intercept. So to find that, we plug in 0 for y. X plus 12. Did everyone get the same x value that I did, positive 4?
Yep.
Okay, and what ordered pair would this be if we're looking for the x-intercept?
it's not
4-0.
4, 0? Because we're looking for the x-intercepts, and the x-intercepts are always on the x-axis, so their y value is always 0, right? So we found our x-intercepts, 4, 0. So on your graph, just put a point on 4, 0. All right, so now we have to do the same thing for the y-intercept. We have to find that. So we plug in 0 for x now. So I write x instead of 0. 0 plus 4y equals negative 12. So now that we've done that, we plug 0 in for our x value. Now we just solve for y. Does everyone get the same y value? -3? Alright, so then, once we found our y-intercept, that would be ordered pair what?
0.
Yep, 0, -3. That looks like a 6. That's not right. 0. Okay, so found our y-intercept, 0, -3. So don't move because it's on a y-axis and go down to 3. Bless you. That's that point right there. And then our last step is to draw the line right. So, using your straight edge, just connect the line and I'll do my darndest to make a good one. There we go. Alright. We just graphed using our x and y intercepts. That's a whole lot easier than making a table and plugging in values, isn't it?
Yes.
A lot less work too.
I have a question. How many points are on that line? 2. Everybody agree there's 2 points on that line? Wrong.
A lot.
How many
There is
points?
a lot, yeah.
How many points do you use to graph it?
2.
2. But does that mean there's only 2 points on that line?
No.
No, there's a whole bunch of points. There's a whole bunch of ordered pairs that would make that equation true. Okay, so let's, just for the fun of it, let's pick one. Let's pick an ordered pair that is not one of those 2 points. See if you can tell an ordered pair that your line is going through. Not working ahead, I want everybody doing this right now. Pick an ordered pair.
Positive 7, 2.
Okay, positive 7, 2.
Do you all agree? Look at your graph. Do you think ordered pair 7, 2 lies on that line? Flip your paper back over and be with us from the one side.
-6, -8.
Your line should be, by the way, I'm noticing in some of you, your line isn't going all the way through the coordinate plane. We're going all the way through, not just, a little shrimpy line going through just how far those points are apart. All extended all the way through the coordinate plane, extended all the way through. And then, do you think ordered pair 7, 2 just happens to be one of the points on that line?
Yes.
Okay, how do we know if it really is one of the points? Anybody have any idea?
Because when you line it up together, it lands on the
Okay, but can we tell for sure on a graph?
line. No.
Okay, so what would it have to do? What would that ordered pair have to do? Let's go with that 7, 2, 1. What would it actually have to do? Plug it in and it has to make the equation what? Work, yeah, it has to make the equation work. It has to make it true. So go ahead and let's do some mental math and see if it does.
Go ahead, Mr. Conlon.
Okay, so you guys plug it in on your own and I'll do it too.
Just do it mental math. They don't even put it
Okay.
on the paper. It might confuse them if it's in their notes. So
Okay.
go up to the original equation and let's plug it in.
So, original equation, -3x plus 4y equals -12. Plug in our two values, so we plug in 7 in for x and 2 in for y. -3 times 7 is -21. Plus 8 times, or 4 times 2, 8. All right, what's -21 plus 8? -13. Is -13 equal to -12? Nope, so does 7, 2 work for our graph? No. Even though it looked like it was, once we checked it out algebraically, it turns out that it wasn't a solution. -3, -5. Okay. So let's try -3, -5. So -3 plus 4 times -5. So, -3 times -3, positive 9, plus 4 times -5 is -20, equals -12. 9 minus 20 is -11. That doesn't work either, does it?
What about 8?
What about -2?
So we can keep trying points, but the point is what here? There are other points on there, correct? But they have to satisfy the equation. So you've tried a couple and you're naming some others that we could also keep trying. In other words, if we put in those and they make it true, then we could say they are. So the point being, just any ordered pair that you want to name is not necessarily a solution, but there are an infinite number of them. Can ordered pairs, can points, can solutions have fractions for their x and or y coordinates? What do you think?
What was
Can
that?
x and or y coordinates have fractions? Yes, they can. Yes, they can. So it might be that when we put -3 in for x, using the table method and find the y value, is it gonna be an integer, do you think? Is it gonna be one of those nice numbers? No, it's probably gonna be a fraction.
Alright, so does anyone have any questions so far about graphing using the x and y intercept? Nope. Awesome. So then we'll go to the back side. Alright. So we're given our equation there. Yes, Joss?
Would you subtract 1/3 x from on both sides?
We could certainly do that. 1/3 x minus 1/3 x. And why would we do that, Joss?
Because it's easier to have both the values on both sides. Or
Exactly.
on one side.
Yep. Just like on the front side, our x and y value were on the same side of our equation. And we didn't have to do as many steps. And that's kind of what we did yesterday, where we moved all of our x's and y's over to the same side.
It's on -7 or an arrow.
That is an arrow. Is that better? Okay. So, now we have our new equation that we rewrote. So, to find our x-intercept, we plug in 0, 4, y, right? Now, right now, this says -1/3 x equals -2. And if we're trying to solve for x, how would we get rid of that -1/3?
No, you would change to a fraction.
Change to 0.75. You could take 0.7.
Multiply by both sides.
Okay, I'm hearing a lot of stuff.
Oh, you would do the reciprocal and
Yeah, that's what I heard Michaela say, and now Joss is saying it. We could multiply by the reciprocal to get it by itself. So, what's the reciprocal again?
1/3 is negative for 3/1.
Yeah, that's the reciprocal of that, but what is a reciprocal?
Is when you switch the denominator and numerator.
Yes, to make it equal what?
1.
Exactly. So, to get the -1/3 out of there, or to get it to equal 1, what's the reciprocal of -1/3?
3.
And then we multiply both sides by 3/1, right? So, these are reciprocals, so they cancel out. And we're just left with x on this side. Equals -2. 1. And what's -2 times -3/1? Positive 6. And that's our x-intercept, right? Because that's what we were trying to find. So on our graph, what ordered pair would that be?
6, 0.
6, 0? Okay, there's 1 point. Now, since we found that, we can move on to our y-intercept. No, actually, let's go away. All right, so now find your y-intercept. All right, did everyone get the same y value that I did? -2? Wonderful. So that will be ordered pair 0, -2, right? So now that we found our y-intercept, we just graph that point. And then the last thing we do is what?
Draw a line.
Draw a line. Yep. And we make sure that we extend our line all the way through our graph. Does our
What is
graph-
that again?
Hmm?
What do you say it's all the way through again?
That's just to show that our line goes on forever. Like if we plug in a really big x value, like 100, we would get some sort of value, but our graph only goes to 10. So we extend it to show that it goes on forever. All right, so does anyone have any questions about graphing with x and y intercepts?